Okay, here we go. We're going to be learning about graphing linear equations in standard form. This is lesson 2.4. And let's get started. So when we're talking about the standard form of an equation, so this is in your note packet, like a box for you to fill in with the vocabulary word. Obviously, writing it and having more practice by writing it might help you remember it. But in this case, we have the literal equation where the variable x and y are on the same side of the equation. So ax plus by is equal to c. The constant is on the right. And a and b are not both 0. So in your textbook example, remember this is just copied and pasted, you want to write the equation in slope-intercept form. Now, this is just one way to do it, right? We've been practicing graphing in slope-intercept form, so you can identify the slope like they did and identify the y-intercept and then graph. I'm going to show you another way to do this and leave it in standard form. So we have negative 2x plus 3y is equal to negative 6. Now notice that c right here is divisible by both coefficients, 3 and negative 2. So sometimes putting it into slope-intercept form takes a little bit of time, and I'm going to show you a way in which we can do it a little quicker. So I'm going to make a little table, right? One thing we know is that when we're talking about the x-intercept, the y-coordinate is 0, and when we're talking about the y-intercept, the x-coordinate is 0. So we can make two different equations from this to solve. So we know that we can do this. So x-intercept, I'll make a little table actually, and y-intercept. All right. So when it crosses the x-axis, when we have the x-intercept, y is equal to 0. When we're doing the y-intercept over here, x is equal to 0. So imagine, if you will, for trying to find the x-intercept, if y is 0, right? Imagine, well, that really didn't really do anything, did it? I was going to try to make it like a solid, but I can't. All right. So in this case, we'll erase that. Oh, why don't we do this? Look at that. When you have the x-intercept, y is 0. How's that? That makes it look a little bit like it's gone. All right. So we have this equation, right? Because 0 times anything, and 0 times 3 is 0. So we are solving negative 2x is equal to, because that's an equal to, negative 6. All right. In class, I'll be able to like put my finger over the variable, right? But on this, I can't. So I was trying to find something to cover it up, and I just didn't do a very good job. Okay, so if we're solving this part of the equation, we can divide both sides by negative 2 and quickly get to the fact that we have negative 6 divided by negative 2 is a positive 3. So it's going to cross the x-axis at 3, all right? That's going to be 3, 0. All right, for the y-intercept, so we'll put the rest of the equation back here, and then do the little eraser and say, well, for the y-intercept, we have that the x-coordinate, or x is 0, right? So x times negative 2 is 0. The whole term disappears, and we're actually solving this equation, 3y is equal to negative 6. So divide by 3, and y is equal to negative 2. And then if you go over to the graph, and let's do a color like, I don't know, purple, just to highlight it, it's crossing x at 3, right here. That's the x-intercept, and y at -2 right here. And technically, those would have been two really quick and easy ways to get these two values, which gave you 2 points that you could then draw your line. And I know I took like a really long time because I was trying to figure that out, but starting from this original equation without having to first change it into slope-intercept form. All right. I'm going to clear this, and then we'll do a couple examples, and we'll examine them and see if we can do it this way. So we'll try doing it this way, and if not, we have to do it this way. We'll do it both ways. All right. Oops, I need a pointer. So if if we have this line, right? We look at the coefficients, 1, right? -2 is divisible by 1. So it's super easy because if we cover up y, if y is equal to 0, the x-intercept is equal to -2, and the y-intercept, when the x-coordinate is 0, is also equal to -2. So we could easily graph -2 and -2 without having to, subtract x. There's nothing to divide by, but then you still have to identify the slope, identify the y-intercept, which is here, and then, you know, you're just finding another point on that line. So I'll do my best to, I know that that point's on the line, that point's on the line. Try to draw this, straight lines. The lines are going to be the worst. All right, this is number 1. Okay, right there. So I'll try to change colors every time I do a problem. All right. I can do blue on this graph too. Over here, let's see, 6, we could divide that by a -2, and 6 can be divided by -2. So I could go ahead and set this up. I can use my little table values here, my x-intercept and my y-intercept. Again, you can put it in slope-intercept form, but here, if the y-coordinate is 0, 2 times 0 is 0, that whole term disappears. I'm solving -1/2 x is equal to 6. And remember that when you're dividing by a -1/2, it's the same as multiplying. So I'm going to be multiplying by a -2 here, multiplied by -2 here. Now, this one's going to make the intercept's going to be kind of crazy because it's a -12, and that I know is going to go off my coordinate plane here. But finding my y-intercept, this term is 0 because x times, 0 times anything is 0. So I'm solving 2y is equal to 6. And so y is equal to 6 divided by 2, which is 3. So I can graph on the y-axis 3, and then 1, 2. Okay. Yeah, maybe about right there. Now, this is where you are going to use a ruler, okay? If I had put it into slope-intercept form, remember I'd be, adding the 1/2 x here, adding the 1/2 x here. So I would get 2y is equal to 1/2 x plus 6. Then I'm dividing both sides by 2, so I would get y is equal to 1/4 x plus 6, plus 3. So that's that y-intercept. So really, I could kind of do 1, 2, 3, 4. For me, it's going to be easier if I do this to count back, just so I kind of have a little bit more of a basis to draw this line, because I'll never get it straight. Wow. Not my worst one yet. All right, problem number 2. There's that. It's not a very steep line, but it is a positive slope. Okay, but with a ruler, you could have gotten the same thing, okay? Looking at 3. Number 3, I could easily, here's the problem with number 3. Since it's 0, right? If I did 0 divided by anything is 0, that means that it's crossing right here, right? At the X and Y is there. And that means I only have 1 point. So I definitely need a different point. So for this one, let's go ahead and put it into slope-intercept form. So this is how you'll decide, right? Because I need at least 2 points to graph a line. So I am going to add 2 over 3x to both sides. Okay? So let's see, if y is equal to 2 over 3x, and I know that it's crossing at 0, I can go up 2 and to the right 3 to get my second point. Okay, and then I can draw that line, and that's line number 3 in green. Okay, so I had to put that in slope-intercept form. Same thing with number 4. Slope-intercept form is going to be needed because 5 is not divisible by 2 evenly. So we're looking for things that would divide evenly in order to use this quick trick, I would call it, or tip, or another method of solving for the intercepts when it's in standard form. You just want to have a lot of tools to be able to do a lot of different things. All right, so let's subtract the 2x from both sides. And so y is equal to a negative 2x plus 5. That means that my slope is a negative 2 and my y-intercept is a 5. So I'm going to cross at 5. 1, 2, 3, 4, 5. And so negative 2 would be down 2 and over 1, down 2 and over 1, down 2 and over 1. But it could also be up 2 and back 1, up 2 and back 1. It gives me a lot of little line dots to... I wish I had a ruler. I wish I had a ruler. I wish I had a ruler. Okay, this was number 4. All right, but definitely use a ruler. Okay, hope you were able to copy all of that down because I am going to go ahead and clear that for you. All right, this doesn't have graph paper, so I'm not going to do this on here, but if we need to, if anybody has any questions or you want to watch this video in class, we can definitely do that as an extra example. So it's time for the vocabulary and concept check. Please select one of the 2. So there are 2 choices. Make sure that you're identifying which one you're doing and give me a thorough explanation. This is a great quote today. Luna Lovegood says, being different isn't a bad thing. It means you're brave enough to be yourself. So I'll leave you with that thought. And again, if you have any questions, be sure to leave them in the last section or question on the Ed Puzzle. Have a great day.